In this part, we will work on important ideas of number theory in AMC 1012, and I can say it will be more than, if you consider also with algebra, more than 100 last minute tips, more than 100 ideas, more than 25 homeworks, and we will focus on sorry, not number theory. Let me tell you, on geometry. We will focus on geometry here. We will work on important ideas. We worked on algebra. Here we will work on geometry. After that, we'll work on number theory and combinatorics. And as I said before, if you want to solve problems from SUMEC, Stanford, from any other math exam, or want to learn background ideas, want to prepare for AME, USAMA, or other math exams, want to learn 40, 50 important ideas and formulas in each topic, combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description. Okay, we will work on all these problems, okay, today. Okay, let's try. Okay, AMC 12B Fall 2021. We'll solve AMC problems from AMC 12 and 10, and the ideas are similar. Okay, we want to work on common ideas in AMC 10 and 12. Okay, so try this problem first on your own. Okay, so it says triangle ABC has side length 11, BC 24, CA 20. Okay, so let's consider for example this 1.2 BC, and then we can, for example, divide it by 5.5 is around this point, and this one is 20. We can say it will be around 1. Okay, now it says what? The bisector of BAC intersect BC in point D and intersect the circumcircle of ABC in point E. So let's draw circumcircle of ABC. A bit larger. Okay. This one. Okay. Now our triangle is this ABC. And let's draw the angle bisector. Okay. If we draw angle bisector is 248 to 328, 52, 72, 80. So 248 to 88. It will be some point like this. It will be D, it will be E, which is not A. The circumcircle of BD intersect the line AB in points B and F. Okay. So if we draw circumcircle of BD, let's move it. Okay, a bit smaller. Now it's larger than this. Okay, a bit larger again. It is BDE. Okay, if we can extend line AB, it will be what? Hmm, it will be, let me show you. It will be F. Okay, now it's a CF is what? Okay. Now for this problem, we want to calculate all lengths that are possible. So BD, let me tell you, idea 1 is what? Angle bisector theorem. Okay. Theorem. And it is what? It says BD over CD is AB over AC. We can call it C over B. Idea 2, if we want to calculate BD separately, it will be AC over B plus C. Similarly, idea 3 is CD equals AB over B plus C. Now we can find BD and CD. Try to prove this. Okay, as homework 1, try to... Let's consider these ideas rest of the previous ones, because in algebra I told you some ideas. Okay, we had 72 ideas in my video in algebra, so it will be idea 73, idea 74, idea 75. Okay, we have also some other length, the formula, some for example 80, all other things. I will tell you, try to prove this one. So homework, we had 25 homework. This one, homework 26, prove this one. And idea 76. If we call AD squared, we have two formula for AD. See which of them here useful. 2BC over B plus C times cos A over 2. Idea 77. It is a special case of Schwarz theorem, okay? But Schwarz theorem, you should know is what? Let me tell you, it is exactly what? AD squared is BC minus BD times DC, okay? Now that I've told you these things, we have what? We know that AB is 11, so C is 11, A is 24, B is 20, and we want to find what? We want to find CF. Okay, now you can calculate some length here by the formulas I told you, and then try to see, can you find CF? Try first on your own. And here for CF, let me also tell you something. You should use cosine law. Cosine law in general is what? So much basic, and in many years of AMC useful, I can say around all years of AMC. It's A squared equals B squared cosine rule or cosine law. A squared equals B squared plus C squared minus 2BC cosine A, okay? So here you can use cosine law to find CF and then find the length that we need. Okay, try to rest on your own first. Okay, let's use cosine law to find CF. CF squared, let's write it here. CF squared is what? Is AC squared, or we can say B squared, plus AF squared minus 2 times B times AF cosine A. Okay? Now we want to calculate cosine A. Cosine A is what? If we use cosine law in ABC here, we use cosine law in triangle ACF. Okay? Now we want to use cosine law in triangle ABC. Cosine A is B squared plus C squared minus A squared over 2BC. So we find cosine A, we know B, so the only thing that we need is finding AF. Okay, let me tell you how you can find AF. You can say AB times AF because look, BDFE cyclic quadrilateral, and we have 4 main roots for cyclic quadrilateral. One of them is this 180. If we have, for example, ABCD cyclic quadrilateral, let me draw it like this. This one, it is P, it is ABCD. Okay, so ABCD is cyclic. If and only if PA times PD equals PB times PC. Okay, now here, we can find AD is what? So AB times AF here, by that rule, AB times AF equals AD times AE. Why? Because these 4 points lie on the same circle, so AB times AF equals AD times AE. So here we know AB is what? We know AD is what by this formula? You should find what? AE. Okay, so try to find AE. If you find AE, then the problem will be solved. So try first on your own. Okay, let's use formulas to write all lengths that are possible. C11, C is 11. B is what? Or AC equals 20. Now, by formula, I said BD equals AC over B plus C. A is what? A is 24, so it will be 24 times C is what? 11. Over what? B plus C, which is 31. CD is what? Is AB over B plus C. Is 24 times B, 20 over 31. Okay, now we found BD and CD. AD is what? We know AD squared is BC minus BD times DC. I told you the formula of this. BC is what? Is 20 times 11 minus BD times CD will be 24 squared times 20 times 11 over 31 squared. Okay, now for calculating this, we can factor from 20 times 11, and then it will be 1 minus 24 squared over 31 squared. Let's simplify more. 20 times 11, which will be 220 over 31 squared. Oh, and in the numerator, 31 squared minus 24 squared. Here, I told you in algebra, this identity you can factorize. It's 220 times 31 minus 24, which is 7. 31 plus 24, which is 55. Okay. Now, over 31 squared. It is what? It is AD squared. So, AD will be what? Square root of this. It will be, let's see here, we have what? We can write 220 as 11 times 20. And for 55 also we have same thing. So let's see. 11 times 5 times 4. Okay. Times 7 times 5 times 11 over 31 squared. If we use common denominator, we have 2 11s. So if we take a square root 1 11 times. We have 2 5s times 5. We have 1 4, so we can consider 2 over 31 root 7. It will be 110 over 31 root 7. Now, as I said, we want to find AE. For finding AE, we know AD is what, we know BD is what, we know DC is what, we can find DE. How? Okay, for calculating this, again, we should use second rule in when we have cyclic quadrilateral. For example, when we have A, B, C, D, and when we draw these parts, for example, suppose the intersection is P, then we know AP times PC equals BP times PD, if and only if ABCD is cyclic, okay? So here we found AD, so we know AD times D equals BD times DC, okay? Now, AD is what? 110 over 31 root 7 times D equals BD times DC. BD 2411 over 31 times 2420 over 31. We can cancel 31 from both sides. We can cancel 11 and 0 like this. So root 7. DE equals 24 squared over 37. And so we can conclude DE equals 24 squared over 37. When we divide both sides by root 7, it will be root 7. We multiply both numerator and denominator by root 7. It will be root 7 over 31 times 7. Okay. Now, we want to find AE. AD plus DE is what? Is AE. we can use root 7 over 31. If we factor, it will be 110 plus 24 squared over 7. Okay, now we found AE. So after that, we can find AF. Okay, so try the rest on your own. Okay, now let's calculate. We wanted to calculate AE then AFs. AE is what? Is root 7 over 31. And here we can factor also. Let's see, we can factor for calculating AE. For DE here, we have 24 squared. Also, we have 2. So let's multiply it by 2. Then here we have 2. Then when here also we have times 2. Okay, so here we have times 2. Let's see for DE. We have root 7. Okay, times 2. Now we can also factor from 2. So it will be 2 root 7. And it will be what? It will be 55 plus 24 squared, which is 576 over 7. If you use common denominator, it will be 2 root 7 over 31. It will be 385. If you use common denominator 7, it will be 385 plus 576. Okay? Now, if we add these two numbers, 2 root 7 over 31 times 5 plus 6, 11. We have 1, 1 plus 7, 8 plus 8, 16. We have 1. 5 plus 3, 8 plus 1, 9. 961 over 7. 961 is what? 31 squared. So we can cancel this one and this one. It will be 31. So it will be 2 times 31 root 7 over 7. Okay, it is AE. Now we want to find AF. So AB times AF equals AD times AE. AB times, let me copy the figure. So if we calculate AB is 11 times AF equals AD. AD was what? 110 root 7 over 31. Times AE, which is this part. 231 root 7 over 7. Now we can cancel this 31, 31, this root 7, root 7, 7. We can cancel this. And also we can divide both sides by 11. It will be 10. So AF is 20. AF is 20. We can conclude BF is 9. So now that we found AF, you can use cosine law in triangle AFC. But before that, you should find cosine A from triangle ABC. We know BC is what? 24. We know A is 24. By using A, B, C, you can find cosine A, then you can use cosine A, and in AFC, you can find CF squared and then CF, okay? So try to find now CF first on your own. Okay, so let's calculate. CF squared is what? Is AF squared plus AC squared 20 squared plus 20 squared minus 2 times 20 times 20 times cosine A. Okay? Now if you want to calculate cosine A, it will be B squared plus C squared minus A squared over 2BC. B squared is what? Is 20 squared. C squared is what? 11 squared. A squared is what? 24 squared over 2 times B times C. 2 times 20 times 11. Okay, so the numerator will be what? Will be 400 plus 121 minus 576. Okay? Over 2 times 20 times 11. And now if we calculate, it will be 521 minus, so let's write 1 minus, okay, minus 576 over, let's write it 40 times 11. It will be what? Negative 55 on, we can cancel 40 times 11, so we can say negative 1 over, if we divide 5, negative 1 over 8. Okay, 5 here, 8, 11 will be cancelled, so this one will be negative 1 over 8. So we can say CF squared equals 400 plus 400. Now minus minus will be plus 8. It will be 2, 10, 10. So plus 100. So it will be 900. So CF equals what? Equals 30. Okay, we could solve also with easier ways, but I wanted to tell you all these ideas that how, for example, to work on problems related to geometry. For example, sometimes we have angle bisectors, sometimes we have medians, it depends. You can see we have what, and then try to solve the problem like this. Okay. Okay, next problem is a problem related to coordinate geometry. We have some important ideas in coordinate geometry, and so this problem is related to, as I said, let me write coordinate geometry, and I want to tell you some ideas in coordinate geometry that in each year some of them are useful. So try this problem first on your own. Okay, for this problem, first we say, okay, ax minus y whole squared is a squared, okay? Or let's consider this part. If you take a square root, we have x plus ay equals what? Plus minus 2a. What about this one? So first, plus minus 2a, we can conclude what? Because we know a is a constant. We can conclude there are two lines. Okay, and the lines are what? We can say ay equals negative x plus minus 2a. And we can conclude y equals negative x over a plus minus 2. And a is not 0. The problem says for a positive. Now let's consider second one. And two parallel lines. Second line will be what? Ax minus y equals plus minus a. So we can take y to right hand side and switch left hand side, right hand side. Y equals ax minus plus a, or plus minus a. And here we can conclude, okay, we have again two lines. Okay, the slope here is negative, that's right, the slope of these two parallel lines equal to negative 1 over a. Slope here is what? Is a. So the product of slopes equal to what? Negative 1. And we know when the product of slopes equal to negative 1, they are perpendicular. So let me tell you idea 81, idea 82. If S1, S2 equals negative 1, then these lines, for example, with slope S1 and S2, they are perpendicular to each other. Okay? For example, I83, which is obvious if S1 equals S2, then there are parallel lines, and another one. Idea 84. For this problem, because we want to calculate the area, let me write idea 84 here. We want to find distance of two parallel lines. Okay, for calculating the area, it's useful. If we have ax plus by plus c1 equal to 0, we can write two parallel lines like this, ax plus by plus c2 equal to 0. So the distance, there are parallel lines, and the distance is d. So d equals absolute value of c1 minus c2 over square root of a squared plus b squared. Okay, so now try to find the answer of the problem by using these ideas. Okay, so look, we have two parallel lines like these. Two parallel lines like this. And we want to see what it says interior of a quadrilateral. Because they are perpendicular, so it will be a rectangle. Where A is a positive real number, what is the area of this region in terms of A? Okay. So, for example, we can say we want to find in terms of A. These two lines, the first two lines. And y-intercept is 2 and negative 2. And the slope is what is 1 negative 1 over A. Okay, if we draw these two lines, for example, it will be something like this. And this one it will be plus minus A y-intercept, and it is A. For example, if A is 1, it will be what? Negative 1 like this. Then when A is 1, it will be what? X plus minus 1. So it will be something like this. Let me show you. Okay, now in general, for example, suppose for any A, we have a rectangle. Now we want to find this distance. For example, this distance is d1. This distance is d2. We want to find d1 times d2. So d1 is what? If we consider these two lines, it will be what? Y plus x over a minus 2 equals 0. Y plus x over a plus 2 equals 0. So it will be absolute value of c1 minus c2, which is 4 over square root of a squared plus b squared is 1 plus 1 over a squared. d2 is what? Is for these two lines. It will be y minus ax plus a equals 0, y minus ax minus a equals 0. So here a positive, so this minus this c1 minus c2, if we use this formula, it will be 2a over square root of 1 plus a squared. Now we want to calculate d1 times d2. d1 times d2 will be what? Will be 4 over this part. You can write it as square root of a squared plus 1 over a squared times 2a over 1 plus a squared. So it will be 4 here, a squared. If you take it outside square root, it will be a. 4a over a squared plus 1 and times 2a over a squared plus 1. So it will be 8a squared over a squared plus 1. So it will be which choice? Choice D. Okay? Okay, let me tell you some other ideas in coordinate geometry. For example, idea 84, idea 85. So suppose, for example, we have a point and you want to find distance of this point from this line. It will be x0, y0, and here it will be ax plus by plus c equals 0. So the distance d here is absolute value of ax0 plus by0 plus c over square root of a squared plus b squared. Okay? And we know distance of 2 points. And distance of 2 points is so much easy. For example, x1, y1, qx2, y2. If you want to find, at first let me tell you slope is what? A slope is y2 minus y1 over x2 minus x1. It's idea 86, idea 87. The equation of this line is y minus y1 equals s times x minus x1. And distance of these two things here, by Pythagorean theorem, we can say x2 minus x1 whole squared plus y2 minus y1 whole squared. Okay, so this coordinate geometry. And for example, idea 88, two parallel lines, two things. Okay, now if you have these lines on circle, for example, idea 89. If you have a circle and you want to know equation of that is what? You can say For example, suppose it's x0, y0, and the distance is r. So equation of that is x minus x0 squared plus y minus y0 whole squared equals 1 equals r squared. And also for idea 90, for parabola, for example, vertex opens up, opens down. And also idea 91, hyperbola. You should know, for example, the vertex and other properties of that asymptotes. Here, parabola vertex, it opens up, opens down, all properties. And for example, directrix is what in some problems directrix useful. For example, focus and something like this. Next one is 92 ovals or ellipses. For example, the foci, other properties. Here we have, let's write instead of oval, let's write ellipse. And okay, if you want to know the properties are what exactly, as I said before, feel free to send message to my WhatsApp number in the description. Okay, let's work on next idea. Try this problem, AMC 12A 2022. The idea here we want to use is also useful for AMC 10. Okay, so in AMC 10 also we have some problems exactly with the same idea. Try this problem first on your own. For solving this problem, let me tell you ratio lemma. Not ratio lemma. I call it double Pythagorean theorem. So 92, 93. Idea 93, double Pythagorean theorem. So we can call, for example, one idea Pythagorean theorem that is useful. Let's call it idea 94. Idea 93, Pythagorean theorem. Also, let me tell you this first, then after this problem, I will tell you some other ideas, like, for example, phase theorem and something like that. So, Pythagorean theorem, we know is what? It's obvious. Double Pythagorean theorem is like this one. Let me show you, is something on one side of a point P, sometimes on two sides of P. It is what? Let me explain for you. Okay, so when we have P, if it is xy, zw, or here P, if it is xy, zw. Okay, for both these things, we can say what? We can say here, x squared minus y squared equals z squared minus w squared. The same thing here, x squared minus y squared equals z squared minus w squared. You can prove it as homework. Let me tell you, it will be homework what? Homework. Here I said to prove some terms. Homework 26. Okay, homework 27. It's easy. Homework 27, prove by Pythagorean theorem. You can easily prove this. Now use double Pythagorean theorem to solve the problem. Okay, let's draw the figure. Here we have this part, this part, this part, this one. Okay. Let me draw a greater figure. Here, for example, like this. Okay. And it is isosceles triangle 1, 2, 1, 2. Okay. Now it says which size. I think if we call it A, B, C, D, it will be okay. BC less than AD. Yes, AB equals CD. PA, PB, PCBD 1. Okay, for example, we can consider P inside or outside. Both of them are okay. Okay, so for example, if P is outside, PA is 1, PB 2, PC 3, PD 4. So, because we can, for example, it's better to define this one here. PD, PC, PB. Okay. Now, if we draw altitudes, let's see what we have. Okay, because I want to have more space to draw these things, let me define it like this one, and like this. Okay. Now I draw perpendicular from P. When we have trapezoid, one useful idea 94. When you have trapezoid, especially isosceles trapezoid, draw altitude. Okay, it's so much help. Here we draw altitude of this isosceles trapezoid. Okay. And then I draw this perpendicular to use double Pythagorean theorem. Okay. Now I consider this one as x, this one as y, this one as z. Because this is isosceles, these two triangles are congruent, so this is z, this is z. Now the problem says BC over AD is what? So BC over AD is what in terms of x, y, z is x plus y over x plus y plus 2z. Now by double Pythagorean theorem, we know that PA squared minus PD squared is what? Or let's say PD squared is better. That one also is okay. PD squared minus PA squared. One thing you can say, okay, 4 squared minus 1 squared, 16 minus 1, 15. Also, we can say PD by double Pythagorean theorem. Here, look, if you want to prove this part, you can say z squared. Let me, for example, write it as rs. They are equal to r squared minus s squared. Try to prove also. This part is so much easier. You should write 2 Pythagorean theorems here and 2 here, 4 Pythagorean theorems in total. So this part is what? Is z plus, we don't know, it is what? So we call this, we know this part, sorry, is x. So we can say this part is y. We can say it is equal to pd squared, here is what? Y plus z squared minus x plus z squared, okay? And if we write pc squared minus pb squared, we know it is 3 squared minus 2 squared, okay? 9 minus 4, which is 5. Also, it is equal to what? It is equal to y squared minus x squared. So consider these two things, and by using these two equations, you can find the thing that the problem wants. Try rest on your own. Okay, let's calculate. Here, again, we use the formula, the idea I told you, when we have something a squared minus b squared, this minus this will be y minus x. And we can do this, or let's do something else. Here, you can say y squared plus z squared will be cancelled. It will be plus 2yz minus x squared minus 2xz. I mean, y squared minus x squared is 5, so it's 5 plus 2 z times y minus x. If you subtract 5, it's 10, and divide by 2, z times y minus x equals 10 over 2, 5. If you simplify, it will be this. Now here, for calculating this, I multiply both numerator and denominator by y minus x. So here it will be y squared minus x squared. Here it will be y squared minus x squared. Also, with the other way, you can solve this. 2zy minus x. So y squared minus x squared is 5. 5 plus z times y minus x is 5 times 2, 10. 5 over 15, which is 1/3. Okay? So I told you this one, idea 94. Idea 95, Thayer's theorem. Thayer's theorem is what? We can say somehow application of similar triangles. When this one is parallel to this one, it is A, B, C. It is D. You can say D is parallel to, or let's write it here. D is parallel to BC. Then we can conclude AD over AB equals AE over AC equals DE over BC. Also, we can say we can conclude AD over DB equals midpoint theorem, a special case of that, when D and E are midpoints of AB and AC respectively. A over EC. Also, we can say if we have these things, we can prove that it is parallel, so if and only if. Idea 96, I told you to use cosine laws, we have sine law. A over sine A equals B over sine B equals C over sine C. In problems of geometric problems of AMC, pay attention to similar triangles. And for example, the criteria, for example, two angles or two ratio of two sides and angle between. And the next one, congruent triangles. Idea 99, Schwarz theorem. Idea 100, ratio lemma. So let me tell you, Schwarz theorem is what, and also ratio lemma is what. Okay, so here, for example, it is A, B, C. It is P, it is D, it is X, it is Y, it is B, it is C. XP squared plus YC squared equals A times D squared plus XY. Okay. Okay. Another thing, we can call it ratio lemma, or you can call it, for example, double sine law. Okay, because again, like double Pythagorean theorem, we should use two sine laws. Here, for example, it is ABC. Again, we have P, we have 1, 2. Sine A1 over sine A2 equals BP over PC times B over C. Okay, or instead of B over C, you can write sine B over sine C. Idea 101. If you draw medians, for example, AG over GM, the ratio they create is what? Is 2 over 1. Okay. So I told you these things. This one, Pythagorean theorem, cosine law, sine law, Thayer's theorem, similar triangles, congruent triangles, Schwarz theorem, sine, double sine law, or ratio lemma, we call it. Ratio lemma. And okay, also we have some more formulas. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description. Okay, 2021 fall AMC 12A. Let's raise this fall. Okay. So let's try this problem from AMC 12. Again, the idea here we use also useful in AMC 10, also in problems of 2022 in last AMC. Okay. So try this problem first on your own. So this point, look, is D. So try this problem first on your own, and then we will try together. کنیم. Okay, so for this problem it says ABCD be an isosceles trapezoid. BC is parallel to AD. Okay, so because it is isosceles, this equals this. And then points x and y lie on diagonal AC with x between A and Y. Okay, as shown in the figure, suppose AXD 90, BYC 90, AX equals 3, XY 1, YC 2. What is the area of ABCD? Okay, so let's see again. As I told you, for example, try to see which triangles are similar, which triangles are congruent. You know, if this is alpha, this one is also alpha. Because of similar triangles. If this one is, so this one is 90 minus alpha, 90 minus alpha, so these two triangles are similar. Okay? What about these two triangles? Can you say anything about that? It is alpha, it is 90 minus alpha. So, here, we know 90 minus alpha 2, 90 minus alpha 3. So the ratio of this to this is 3 over 2. So we can consider it is 2x, it is 3x. This one is 2y, this one, this length is 3y. Okay? Now we know BDC equals AB. So we can use Pythagorean theorem. Because DC equals AB, we can say DC squared equals AB squared. So try the rest on your own because the rest is not hard. Okay, if you use Pythagorean theorem, DC squared is 3 squared, which is, let's try, 3 squared plus 3x whole squared equals AB squared. Pythagorean theorem here is 2x whole squared plus 4 squared. So it will be 9 plus 9x squared equals 4x squared plus 16. So it will be 5x squared equals 16 minus 9, 7. So here, the problem, x will be what? X squared will be 7 over 5. Or we can conclude x equal to root 7 over 5. Now, it says the area is what? Okay. The area is what? Here is 3x, here is 2x. So here we can write it, if we rationalize root 35 over 5. Area of this part is 2x times this part over 2. Area of that part is 3x times 2x over times this one over 2. So it will be AC times 2x over 2 plus AC times 3x over 2. It will be AC if you factor AC over 2 times 2x times 3 plus 2x plus 3x 5x. AC is what? 3 plus 3, 6 over 2, 3. So 3 times 5, 15x. X is what? This part. So 15 times root 35 over 5. So if we divide by 3 by 5, it will be 3 root 35. Okay. Let me tell you also some ideas about area. For area, if we have, how many ideas have we told you? 101, 102. Okay. Area of a triangle. We have, and also then area of quadrilateral in general. For ABC, first area is, for example, HA altitude through A times A over 2 is first formula. Idea 103, next formula is area equals 1 half BC sine A. Idea 104 is Heron's formula, which you can say, okay, if S is A plus B plus C over 2, area is the square root of S times S minus A times S minus B times S minus C. And idea 105, another form of Heron's formula. When, for example, we have square root of something, the length. Okay, if you want to know this formula and other things, as I said before, feel free to send a message to my WhatsApp number, idea 105, idea 106. If you have a quadrilateral, for example, like this, ABCD, and if we draw diagonals, so suppose it is alpha, a special case of that will be area of rhombus. Area here is what? Is 1 half AC times BD times sine alpha. Okay. We have these formulas of areas. Also, we had a video. We worked on ideas of algebra, here ideas of geometry. We'll work on ideas of number theory and combinatorics. Okay, if you want to learn other ideas, want to solve more homework, as I said before, feel free, send message, my WhatsApp number in the description.